Hey everyone, welcome back. Today we're diving into a fascinating and somewhat intimidating phenomenon from our very own sun solar storms. So buckle up because this is going to be an explosive ride. Solar storms, also known as geomagnetic storms, are disturbances in the Earth's magnetosphere caused by solar wind and solar flares. But what exactly triggers these storms and how do they affect us here on Earth? To understand solar storms, we first need to understand the sun itself. Our sun is a giant, boiling ball of plasma made up of charged particles like electrons and protons. It's constantly in motion with magnetic fields twisting and turning within it. Sometimes these magnetic fields become twisted and tangled, causing areas of intense magnetic activity called sunspots. When the energy stored in these twisted magnetic fields is suddenly released, it can result in solar flares, massive bursts of radiation. But that's not all. Along with solar flares, we have coronal mass ejections or CMAs. These are huge bubbles of gas threaded with magnetic field lines that are ejected from the sun over the course of several hours. When a CME heads towards Earth, it can interact with our planet's magnetic field. This interaction can cause a geomagnetic storm, which is what we commonly refer to as a solar storm. Now, let's talk about what happens when these solar storms hit Earth. The effects can be both beautiful and disruptive. One of the most stunning effects is the auroras, the northern and southern lights. Auroras are created when charged particles from the sun collide with atoms in Earth's atmosphere, causing them to glow. While these light shows are incredible to watch, solar storms can also cause problems. Solar storms can disrupt satellite operations, GPS navigation, and even power grids. The charged particles can induce electric currents in power lines, potentially leading to large-scale power outages. They can also pose a risk to astronauts in space who don't have the protection of Earth's atmosphere. Scientists and engineers are constantly monitoring solar activity to predict and prepare for solar storms. Space weather centers around the world use satellites and ground-based instruments to track the sun's behavior and issue warnings when necessary. One of the most famous solar storms in history is the Carrington event of 1859. Named after British astronomer Richard Carrington, this massive geomagnetic storm caused auroras so bright that people in the northeastern United States could read newspapers at night by their light. Telegraph systems all over Europe and North America failed, with some operators even experiencing electric shocks. If a storm of that magnitude were to hit us today, it could have severe consequences for our modern technology-dependent society. That's why understanding and predicting solar storms is more important than ever. Solar activity follows an 11-year cycle with periods of high and low activity. Right now, we are entering solar cycle 25, which scientists predict will peak around 2025. During peak activity, the frequency and intensity of solar storms increase. With advancements in technology, we are getting better at predicting solar storms. Space missions like NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter are helping us learn more about the sun and its behavior. So, while solar storms are a reminder of the sun's immense power, they're also a fascinating area of study that helps us understand our place in the universe a little better. Thanks for joining me on this cosmic journey. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell so you never miss an update. Until next time, stay curious and keep exploring. Check out our other videos on space and science, and let us know in the comments what topics you'd like us to cover next.